do have, you know, please maintain your speed below 250 knots. You do get that every once in a while, but even Grand Rapids or Great Lakes Approach said, oh, yeah, our jets rarely pull it back to 250. They'll come in 300, 310. Yeah, oops. So, that's the only stop sign. Okay, what I'll do is you're gonna have a combustion heater quiz, which is super simple. One question, everybody clear? You've got to look up the AD for the 414 and fill it out. And then you have an oxygen quiz. So I'm thinking tomorrow morning, oxygen quiz. Name the three. Who can name one component, major component, in a pressurization system? Yes?
Outflow valve.
Outflow valve. Beautiful. What's the job of the outflow valve? Release the pressure or?
Regulate.
Say what? Regulate, maintain. Okay? If we're going to use it, let's use the word technically. We're not going to use the word regulate. Regulate? Use the word regulate. What does it do? Because if you're overpressurized, it's supposed to act as a safety as well. Okay? So it works to maintain a consistent pressure. Good? Very good. All right. So you'll need to be able to name three of those components, and then you'll need to explain a verbal explanation of you and a partner of the pressurization system on the 414 as part of the quiz. That's worth, I think it's worth about 10 points on the quiz. So I have to be able to fully explain that. Okay? And then there are 8 multiple guess questions. I don't think it'll take a whole lot of time tomorrow morning.
Where the multiple guess?
Yeah. Yes, sir. Yep. All right. You can't see what I see from the center. There you go. Let's hop into combustion heaters, aircraft cabin heaters. All right, cabin heater system, combustion heaters. We have cabin heater and we have combustion heater. All right? They do the same thing. And then heater inspection practices, we're going to talk about, this is actually the word Janitrol. Probably one of the biggest names in aircraft systems. You're going to see it in the service manual. Most of the aircraft use Janitrol, and I think after all the lawsuits and bazillions of AVs, eventually they sold out. But Janitrol is still in service manuals. That is a combustion heater. Okay? Students should understand how the cabin heater operates. You should understand proper inspection of exhaust heaters, and students should understand operation of a combustion heater. Okay? So cabin heater systems, okay? Smaller aircraft, general aviation, a 172, a 182, okay? They can still fly at 20 degrees and the pilots still feel comfortable. How does that happen? Yeah, so they're going to take air, ram air. When I use the word ram air, what am I talking about? Yeah, it's going through a scoop. Okay, so outside air, as you're flying through the air, you've got all this air, and you know we're moving through the air, so it works out well. So we can just scoop some of that air, and we're going to route that around something like this. But what's inside here? So this bad boy sits like this. Notice it has a hole here, hole here, hole here. These are your cylinders running down. Okay? And then it comes out the exhaust. So this is part of your muffler. But on the outside, you have this little almost a 1-inch space. And they're going to run a shroud on the outside, and they're going to take ram air and they're going to run that across the outside of this. Okay, inside the shroud, which is normally stainless. Then you're going to take some of that air and they're going to route it to 2 places most of the time. Cabin, which they can use for defrost as well, and carb heat. And we don't like ice in carburetors. Makes the pilot sweat, okay? All right. This is another system just like this. I know, you're saying, man, that looks gnarly, doesn't it? And this is a super common system. What engineer thought, man, I'll put a whole pile of bolts there and stick them through there? It's pretty cool because it dissipates. Pretty bad because it's punches cracks, lots of stress cracks because all these little tiny welds. Like, okay, let's weld all that. Well, that's a very terrible stress point. So you get all these little cracks, we call them little smiley faces between the bolts. And so, on your OZPs for power plant, a common practical is that you open the shroud, 3 little screws, open it, take your mirror down there, and you thought the oxygen bottle's hard? No, engineer made this really hard. So you got to take it down there and take your mirror inside the little shroud and make sure there's no cracks, no smiley faces. Okay? Or you can shine a light on the outside of it, and then you can get a mirror in here, and sometimes you can see cracks that way as well. But these do the same thing. The reason why they have studs is to dissipate heat into the ram air. Okay? What's the problem if this bad boy's cracked? Puts the pilot to sleep for permanent, right? Okay, because you get carbon monoxide. So now we have exhaust gases cracking through and going inside the cabin. Okay, a lot like you this morning, right? Starting to doze a little bit. So same thing happens inside the cockpit. This is a cabin heater system. Now, on the larger jets, what do we use? We use a bleed air system, okay? So we could use bleed air, turbine engine aircraft. We use an air cycle conditioning system. We don't call it an air conditioning system. We call it an air cycle conditioning. Because we can condition the air by the mixture box. We can reheat it. Oh man, Ryan's feeling cold at 75 degrees. Let's heat it back up to 80. Yes. Okay? Yes. All right, so engine bleed air will be mixed again with it. Then we have an electric heating system. Not very common. Not very common. Why is that? A lot of mojo. Yeah, it takes a lot of amperage to kick that in, okay? Even, I tell you what, if it ever does warm up in this great state, you go out and run the 414 and you try to turn the air conditioning on, our air conditioning like the vapor cycle system, with only one alternator, and the whole engine's like, with just one engine running. And then so you got to kick the other engine on and then finally get it up to like, I can't remember, maybe it's at least 1,800 RPMs or 1,700 RPMs on both engines for the alternator to be able to support just the vapor cycle pump kicking on. So it takes some serious. So even your heating is going to take even more current draw. Okay. Exhaust shrouds. So we just went over that. Exhaust shrouds where you're flying through the air and you'll have this little catch to be able to take in outside air and run it across the outside of a shroud. So we have hot, cold, hot, cold. What's the problem with that? Say what? Moisture. What else though? Okay, so you could have, let's say you have inside here is 1,500 degrees. Hopefully not more than 1,500 or we start cracking. Okay, so let's go safe. Let's say 1,300 degrees. Out here, we're going to run, let's just run 40-degree air across the outside of it. Anybody see any problems? Come on. Temperature difference, which gives us what? Expansion, contrast. Expansion, contrast, right? You got me? And then we decide to fly through a cloud. Cloud holds moisture. Now we got all this water on here, right? Everybody good now? One of the biggest things for us as mechanics, honestly, is this bad boy right here. Is if they do a a flooded start. Okay? How many of your pilots do fuel-injected aircraft? Do fuel-injected aircraft? Okay, fuel-injected aircraft, when they tell you to do it, a hot start on a fuel-injected aircraft is very difficult. It will discourage you as a mechanic and a pilot very, very quickly if you don't know what you're doing, okay? Yes, you will know what you're doing when you leave here. I guarantee it. Because I will start the engine, I will run it hot. I'll put it in red line, then shut it down and make you start it. Just for torture. But so that you know when you get into a really nice airplane, you know what you're doing. You're not sitting there looking at the dash like, I don't know what I'm looking at. Okay? But this is one of the biggest issues is when they flood it. Where does all that fuel go? It hits the exhaust stack inside. And what did I just tell you? We're doing what type of start? A hot or a flooded start. So you're flooding it. All that fuel is going to go into the exhaust, which does what? Yeah, it cools it off, creates a hot spot, which is a potential crack. And so, if you hear, I'm just speaking to you as a mechanic, because I'll tell you about a mistake that I made pretty significantly when I was 18 years old. But you'll hear a backfire, pop, 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 just like a gunshot. And that is fuel hitting the inside of the actual muffler itself, and it creates hot spots. So I had a Mooney, this little pretty peppy Mooney, and the guy takes off, comes around. He was a transit coming from, I want to say he was coming from Florida going to Kentucky, and he came in and he's like, man, I'm getting a smell in the cockpit. So we worked through it. I looked around the exhaust itself, looked around it, and he was in a hurry. Oh, super impatient. Hey, we gotta go. I gotta be in Kentucky. Come on. And he's really annoying me as a new AP, just in my face, sitting there watching you work on the airplane like this. Like, man, just get a grip. Now I'm a little bit bolder. Probably just say, hey, go take a chill pill. So anyway, he's right in my face, working on it, trying to figure out what's going on. So we changed some of what they call skeet and scat hoses. He's like, it's that one melting, which it was melted right here, coming off one of the shrouds. So we changed the skeet, I think it was the scat hose, which is the orange or black, depending on what they are. You saw the orange hoses or black. They're called skeet and scat. Don't ask where that name came from. You can ask Christina afterwards. Anyway. Taxis out on takeoff, comes back around and lands and says, you didn't fix it. Now I'm just ticked. They can take the whole stupid cowling back off and look for it. I never stuck a mirror up in here. Okay? What you can do is you can open that shroud and shine a light here, and then put a mirror while the light's shining here. One of those what are those called? Like a wand lights, kind of the big LED lights. And then use a flashlight and mirror. And there was a significant crack. Number two, I didn't ask the right questions. Did you happen to hear a backfire any time before you took off or at your last place when you filled up with fuel? What did he say after I asked him that one? Oh yeah, I had to do a hot start at the last airport. Cha-ching. What does that tell me? Could have potentially cracked your muffler. Okay? These are super cheap. These are all about $2,000. Okay? And so he was down for another day. But what happened was it kind of hurt my confidence because I was in a hurry. And then number two, I was listening to him instead of just saying, shut up and let me do my job. That's what I should have said. But being a new A&P, because I think I was super fresh. I was probably a month out of A&P school. And yes, I had worked on airplanes before that, but he was just in my face. So it was like, all right, yeah, I got to do this. I got to do this. So, lesson learned. Hopefully a lesson learned. Okay. Any questions on exhaust shroud heaters? Any questions?
Yeah, the one you just put on the floor.
Yes, sir.
So the exhaust goes through it?
The exhaust goes from each, so this is a 4-cylinder. This would be what you would typically find on a 172 or a Mooney or a Cherokee, so that it goes to each hole from the cylinder. Yep.
Goes up the bottom.
Yes, sir. So it will sit, well, this is a baby engine, but this would sit underneath the engine here, okay?
Yep, no, I was just,
Yep, and then, like I said, that 1-inch gap will have a stainless steel cover right around it, and it has screws right down the center of it. Stainless screws, stainless cover, and then that's where your fresh air, ram air, goes around the outside. Okay, good. I have several different exhaust shrouds, exhaust heaters. So this one is an exhaust as well, but it does not have a shroud around it. Okay, see the difference? I wanted you to be able to see the difference here. Okay, this would be a typical exhaust off one stack or one side. For example, the 210, 206 will have this right at the bottom of the stack if it's not a turbocharged. If it's just normal, what we call normally aspirated or normal non-turbo, okay, we'll have just this bad boy right here. And this one, you can see, got a little hot on the inside and deformed. Okay, let me pass this around. It's a little dirty, but that's okay. It'll clean up. All right, so exhaust shroud heater, this is an example from your book of an exhaust shroud heater where your ram air comes in, goes around. Notice it makes it look like it goes through the shroud, doesn't it? Does not go through the middle of the muffler itself. It goes around while these come down, okay? Does that picture seem confusing to anybody? I feel like it's pretty confusing. Okay, so it actually goes around here while your exhaust is inside. All right, here is like a Cherokee 6 or a Saratoga or a Lance style where you have six cylinders pushing in air here. 1, 2, 3, and then 3 on the other side. And then they're using that air from around it in a big, huge shroud to go up to a mixture box. Okay? This is what the shroud would look like. They're very, very thin stainless steel. Okay? Pretty janky. But the system works. Okay? Notice once again we have the studs sticking out. That is a super common crack point. Can you weld it? Send it out for repair. Okay? A lot of liability. Okay? A lot of liability on those. Any questions on the exhaust heater? Yes, sir?
like, in relation to what we learned yesterday,
Yes, sir?
would this not be necessary on a turbocharged system?
On a turbine, like a turbo fan, not a turbocharged. Like you're talking about air cycle?
Yeah.
Yeah.
They use the,
They'll use bleed air at the mixture box to reheat it. Yeah. So but on the 414, we're going to use a really nice hot system.
so this is not a 414?
This is not. It has a whole different system. This would be on a smaller general aviation, such as the little Cherokee, a 182, a 172. Mooney would have this. Typically, your smaller single engines. Got me? Okay. All right. What do you need to know? What do I need to know? Hey, you guys need to know this. I know this is not my class. This is probably Christina's, so she'll yell at me. But, hey, you're supposed to do a pressure test on these. Take a vacuum cleaner, push it to the blow side, because a vacuum cleaner is only an air mover, right? So push it to the blow side, and then you can cover one side with like cardboard. Please be careful with duct tape. I watch some of these students on their O's and P's put duct tape on the exhaust, and it's like, oh, no, you're not my student. You're not my student. Okay? Because it creates a sticky residue, then you go out and light the airplane, start it. But you're supposed to do a pressure test on that, and you can do soap and water on it while you're putting that air through it. And it will also tell you leaks. If you suspect there's a crack in it. So you can put the vacuum cleaner to the blow side on the muffler, and then spray soap and water around the outside, and you'll see what? Bloop, 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 bubbles, okay? If you suspect it. So you can pressure test it. There you go. Very good? How many of you have no idea what I just said?
Use cardboard for your set?
You could use cardboard, you could use rags. I just don't like duct tape on a muffler because it creates a residue. Yeah? Yeah. Where's the big guy? Here we go. Let's do it on this one, okay? So what you can do is you can put the vacuum here, vacuum cleaner on the blow side, okay? Which is only like 2 psi. Everybody good there? And you can put it right there, and then you could block. Right here's 2 couplers. Take the couplers off and block those holes there, and then spray soap and water around here. And if you see bubbles, then we know that there's a compromise between the inside and the outside.
You have to remove the exhaust to be able to pressure test?
Oftentimes, yes. Oftentimes.
Where could the air go?
Sir?
Where could the air go if you left it?
Into your cylinders. Because you have suck, squeeze, bang, blow. One cylinder is going to be on. The exhaust valve is going to be open, so it would go inside that. Yeah.
Round the pump.
Sir?
Round the pump.
Well, it's just not, you're
Pull the exhaust.
sticking it right into your exhaust, you're getting some of that carbon and all that in there. Not my favorite. I'd probably yell at you as your instructor. If you did it in the field, just don't tell me. But, on this one, they're not that difficult. These have like little janky clamps. You can take the clamp off, pop it, and then put the vacuum cleaner on it. It doesn't take long, and it saves lives. 2 good things, right?
So you're spraying soap on the shroud?
Yeah, don't do it while it's hot. No, you're spraying it on the inside of the shroud, so you have to open the shroud slightly. Spray it inside, yeah. Don't do it while it's hot.
Would you have to check the whole way around?
Yeah, but
How do you do that? Is it just, don't you, once you need to remove it the whole way from the shroud, but
flashlight and mirror, you just spray it down in there. It usually finds it pretty well. Yep. Okay. All right, and then operational test with the engine running and cabin heat on. Test for carbon monoxide. Okay. You could do carbon monoxide. We have electrical testers and we have chemical detectors, which I call scratch and sniff. Call this scratch and sniff, right? Okay. We have a $7 to $100 one, which does what? Tells you, you're gonna die. You're gonna die. Okay. We have carbon monoxide is detected, and then we have these that turn brown. Okay. It's actually not $5 anymore. It's now $7. But inflation. So we call them the scratch and sniff. So you could use a scratch and sniff, which I have talked to several pilots at flight schools. No offense. No offense. They have no idea what this is for. Hey, what does it mean if it turns brown? I don't know. Do you know that means you're going to die? So please, if you put one in the airplane, if you get inside an airplane, for example, the 182, you're working on the 182, and you put one of these inside the 182, please tell the owner/operator why you put it in there. Hey, you didn't have a carbon monoxide detector. Now, obviously, you should ask them before you put this one in there. But if they come in for annual, they don't have a carbon monoxide detector or the scratch and sniff, and you put one in there, please tell them why you did it. Hey, if it turns brown, you need to make sure you open a window on the aircraft to get fresh air in quickly, okay? Because it's telling you that you have carbon. Because it's not pulling to the side of the road. This is, okay, you're going to die. You need to get fresh air, okay? Close off the exhaust immediately and get fresh air in there. Okay, that should be what you tell them as pilots or owners, operators. I'm serious. I've asked young pilots, hey, what does that mean if it turns brown? I don't know. You're gonna die. So, open a window quickly and get fresh air in there. Okay, please, everybody get, don't act like you know it all, but just please at least help. If you, a lot of aircraft don't have them in there, you need to tell them, hey, you should have a carbon monoxide detector in there. Okay. Cessnas, why is it important for Cessnas? Let's think logical, mechanical. Yes?
Is it not a legal requirement to have one of those on a single engine plane?
It's definitely not, but we don't have one of them.
Should be, yeah. No, but yeah. Okay, come back to me. Let's think mechanically for a second. Go back to landing gear class. Say it again, Gavin. Steering loops. For Cessnas, that is probably the most common cause of carbon monoxide in there. Is because you're within about 12 inches of your exhaust is your steering rod loops. They're at the bottom, okay? And they'll get leakage. That is a very good way for the pilot to go to sleep permanently, okay? So I'm a big believer in this, okay? All right, now, Josh has been waiting for this. Combustion heater, okay? Combustion heater is super cool. It uses avgas. So it is hooked into the aircraft's fuel system, and it has a drip to it. And so we've got an igniter up here. We've got a fan blower here. All of them are slightly different, but they do essentially the same thing. They'll have a big fan on them so that when you're on the ground taxiing out, it will keep air flowing across that combustion. So it does the same thing, just like this does, where inside it has combustion inside, outside has ram air outside of it, okay? It's hooked into the pressurization system, okay? They will take air from outside, run it across here, heat it up, and can send it to the cabin, okay? And then your air, or from the combustion inside, is then exhausted into overboard outside the aircraft. Okay? These bad boys are like 60,000 BTUs. Be like some of you are like, man, I have no idea. That's like a 3-bedroom house furnace inside your house for a little bitty cabin. I mean, it is kicking. So you got some serious BTUs putting out. It's probably more than my whole garage inside the front of the 414. I think in my garage is like 50,000 BTUs. So, pretty cool. Serious heat. It runs 6 gallons an hour. So, calculate fuel burn with that as well. Okay? So, if you're running the 414 runs 28 to 32 gallons an hour per engine. Full. So, you're running, let's say you're running, you get it up to cruise altitude, we're running 25 gallons an hour. Let's just make it easy. That's 50 gallons an hour on both engines. And then, lo and behold, what are we going to kick on? The combustion heater. So now we're running 56 gallons an hour.
Do you adjust that, or is it just overall? Like the amount of fuel?
You can adjust the thermostat, so as it runs, it burns fuel.
But when it's running, it's same.
That's right.
Same
So somebody
power.
like me is going to burn a lot more because I like it hot. Okay. Yeah. Okay, combustion heater. Here is as simple as I can get. Okay. All right. Combustion heater. So you have combustion air scoop, takes in air from outside, ignites it or drops fuel into it. But this chamber is sealed. Should be sealed. Should be sealed. Okay. It will drip in. Okay. A lot of these will have their own test sensor, so that it will only put a certain amount of spray fuel in there, and then it lights it. Kaboom! And then it will exhaust it. Then we run ventilation air scoop from outside. Notice we have a fan, okay? If you're not moving at 200 miles an hour, the fan needs to be running. And most of these will have a sensor hooked to the landing gear. So boom, you put the landing gear down. As soon as it hits that micro switch, okay, immediately the fan's gonna kick on. Because now I'm not going through the air, okay? So it means, okay, we gotta have enough air. Because if we don't have enough air across here, we're gonna get a crack from overheating the combustion chamber. So it'll keep air flowing across here, and then boom, it will put it into the pressurization system. Or, if it's like the old Apache or the Aztec, which is non-pressurized, it's just gonna go into the little air ducts. Duct. Sorry, a little southern there. A little duct work there, to heat it up, okay? All right. Any sorry, go ahead, Leo.
Is the spray adjusted at all? Or is it
Not
just one
by
set drip?
us. Not by us. Nope. It is, yeah, it is strictly by the company that made it, yep. We're doing an ops check. Does it work? Does it heat up? Is there any fuel leaks? Yes, sir?
What is the thermostat change stuff that you choose on, just to make it cold air? Or
Thermostat is sensing the air here, okay? Normally it's sensing, okay, this is the temperature that we want, so once we reach that temperature outflow, it'll be inside the cabin. Hey, Ryan's finally at 80 degrees, it'll turn that off and on, off and on, off and on. And then we have a thermal switch where if it gets too hot, oh no, you're gonna explode, okay? Anybody see any problems with this?
you go through a cloud, you got moisture that you're picking up.
Okay, good.
Same thing as the exhaust, cracking on it.
What's gonna happen?
It's gonna strike it, it's gonna cool it down, you're gonna get a hot spot.
Good, it's gonna go all over it, yep. They've actually created screens and hopefully, water separators, but they didn't do a very good job with that. Any other issues?
You're running fuel to your nose, you've got a combustion heater in front of your nose, lot of heat, lot of fuel, lot of places for fire.
Okay, and most of the time, just like your oxygen bottle, they put it in an insane place to be able to inspect it. So it is extremely difficult, and and truthfully, the FAA goes after the mechanics for this, which they should, but it is in a very difficult spot to inspect it. And so they'll put this in a place that's really difficult to inspect, be able to inspect this combustion heater for fuel leaks. The slightest little drip could ignite. Now they do have pressure switches where if we don't get enough fuel flow, it's supposed to shut off. There's a lot of safeties there. Okay. All right, combustion heater operation. Ventilating air to warm cabin completely separate from combustion heater. Should be completely separate. If it's not completely separate, we have a problem. The amount of combustion air is controlled by either an air relief valve or differential pressure regulator. The thermostat circuit cycles the fuel on and off. So, Micah likes it at 65, I like it at 80 degrees. So, I'm gonna take more fuel than he will, okay? And so it's gonna cycle on and off more frequently for me. Safety switches prevent heater operation if there is insufficient air, okay? Like I said, put the landing gear down, your blower's supposed to kick on to prevent overheat conditioning. Please be careful, it will shock you to no end. Very high coil or ignition charge, very high. All right, clean and replace fuel filters, pressurize the fuel system to check for leaks. We need to make sure that there's fuel pressure all the way to the combustion heater and there's no leaks. Clean and test, replace a spark plug or ignition plug, whichever one they call it. Ensure inlets and outlets are not plugged. Birds love to get in the front of the combustion heater. You'll see the air scoop on the 414 when you do that inspection. They love it. They crawl up in there and they love to get up inside right where the combustion heater is. Really causes problems if they do get past the screen and all their nest does catch on fire, okay? Follow all manufacturers' inspection criteria. overhaul as recommended. I will tell you, if you do not like ADs, combustion heaters are not your friends, okay? I probably would not be exaggerating to say the 414, off the top of my head, I haven't even looked, probably has 6 ADs just on that one combustion heater alone, okay? And you get into older aircraft, you could have as many as 14 or 15 for one combustion heater. And so typically when it goes to overhaul, it will bring it into compliance. So most of those ADs, old ADs, go away by or complied with by overhaul. Okay? Just nice. Okay. All right. Who needs a break? All right, get a break. 8 o'clock. Be back. One of his questions was, so if we're using a vapor cycle system, which is somewhere in the back of the beach jet back here, or some of the the big jets, they don't use an air cycle system to cool the air. They're going to use like a car with refrigerant. They use that in the beach jet. Some of the smaller jets, Citation 1, 2, whatever. What are they doing for heat then? We don't typically use exhaust shroud heaters on twin recips because we would have to route the exhaust away from the engines all the way up to the stinking cabin. Now we got a problem. Now we're dealing with potential fire hazards, hot exhaust. So how do they do it? Well, typically they're going to run a very, very tiny line, small line off your bleed air, as bleed air off the compressor, one of the compressor sections on both of the engines. What is that going to do for us inside the cabin? It's going to heat, but more importantly, what's it going to do? Pressurize, because we got to stay alive. Okay, we can be cold and still survive. Most of us, not me, but most of us. But what do we really need? We need a pressurization, and so they're going to use a very tiny line. Okay, that's going to supply pressurization, and then we can use the air cycle machine vapor cycle machine to cool the air, condition the air. Okay. Why do they do that on the smaller jets? Well, why logically might we do that? Exactly. We're going to rip too much of the horsepower away from the engine, basically. Too much power away from the engine. So we use a very small line. It's more predictable and more consistent. Okay? Got it? That was a good question, Micah. You have another question. I can see you pondering. What is it?
Maybe I asked earlier, but so if you're using an air cycle system, if you need a heat, you just use bleed air. You don't mess around with any of the.
Correct.
There's,
How do we
there's no
use?
exhaust. It's not like an exhaust on combustion for a recip.
Yes, but please understand, in a air cycle system, the air cycle system itself, or the air cycle machine itself, is not heating it. Where is it getting heated again? At the mixture box with bleed air. It's going to reheat it at the mixture box. All right? And yes, typically, you're going to have to reheat it a lot at altitude. Okay? Everybody good so far? Everybody somewhat clear? All right. I'm going to hit a couple last slides here and we'll be out of here. Okay, combustion heater maintenance. So we have give me the two types of heating systems so far that have been over. Exhaust shroud, which is typically found on what type of aircraft? Single engine recip. Okay, and then the other type is combustion heater. Okay. Clean and replace fuel filters. Pressurized fuel system to check for leaks. Clean, test, replace spark plug. Ensure outlets, inlets. Okay. Everybody clear on we're going to perform our operational check. When we say follow all the manufacturer's inspection criteria, that includes ADs. Okay? There is a bazillion janitrol combustion heater inspection ADs. Okay? Everybody good? All right. First question we have today. section of a turbine engine provides high-pressure bleed air to an air cycle machine for pressurizing and air conditioning? Anyone? Anyone? Yeah. Alpha, low or high pressure. Why wouldn't it be a compressor inlet?
There ain't no pressure yet.
There's no pressure yet. You said it. Good. Ain't no pressure yet. You said it exactly how I just said it. All right, good. And then which, do you understand that, Dave? Okay, good. At which component in an air cycle cooling system does an air undergo a pressure temperature drop? Wah, wah, wah. A. We want to go to the expansion turbine where it undergoes a pressure and temperature drop. So it comes in, it gets compressed, but then it turns around and it goes to an expansion turbine where it can expand and then gets significantly dropped as what goes over it, Elijah? Yeah, ram air, good.
So wouldn't that be the heat exchanger then? Like,
But it's
aren't
having
they
air.
happening at the same time?
So
Maybe
think,
AMD?
hold on. Just take a break for a second. So think about the compressor side, we're just getting squeezed on our air cycle machine out there. It's squeezed.
The board you showed us?
Yeah,
Okay.
the black one there. So it's getting squeezed coming out of the compressor, and then it goes over there, and then what happens when it gets to the wide black part there? It can go down different avenues, and it's gonna slow down and have room to expand. Okay, so it's gonna go over, it's gonna do a pressure drop and a temperature drop. Okay?
The temperature part, portion happened in the heat exchanger though?
I think that's where I know that.
Yeah,
And then more so when it expands again from the expansion turbine? Kind of it's both, no?
it is both, yep, very much.
It doesn't change the pressure, although when it goes into the heat exchanger, does the pressure drop?
Exactly, that's what I would say is, because if I think about some of the other ones, it doesn't necessarily go through a significant pressure drop. It may just cool it off. But in the expansion turbine, it does undergo a significant pressure change, yeah.
So in the Lockheed one, the T-33, that one is an expansion turbine, right, off the box.
Yes, sir.
So that just means it comes in through the fan and then out through the middle with the expansion, and if it were the other way around, it's compression.
Yeah, I didn't think about that, yep. Well said. I was trying to think through the picture that I showed yesterday. Let me see if I can show it real quick.
So compressed air would be hotter than when you expand it, it automatically drops temperature.
Because if I look at this one here, Leo, if this helps. Our discussion. So you've got primary heat exchanger here, but where does it significantly go change? And I think this is where the FAA question is coming from, is it doesn't undergo it significantly here. It undergoes it significantly or most probably in your turbine over here, part of the same system. I think that's the thought there.
But that's a compressor, it's compressing, it's not expanding.
Until it gets down here, correct. Because compressor is gonna push our pressure up, temp up, but then what happens is it leaves the ram air side of it, comes into the turbine, then that's where we're getting the pressure and temp drop at the turbine. Comes back
It's a
through.
compressing turbine on the left and on the right side.
Correct.
It's expanding, right?
Yep, and so I think the question,
Where does the temperature drop according to that picture? It's on the compressor side, which is not true.
no, it's gonna be on the
Should be, that
pressure
should be.
up, pressure, temp up, come through, pressure down, temp down.
Okay, I was looking at the blue, thinking that was temperature, but it's not.
No. So that's, I think think this is the idea what they're talking about here.
Is that one out there has expansion turbine?
That's,
Mock-up one?
yeah, they're using intercooler itself as the air expansion turbine where the air's gonna expand.
Yeah, that's where I'm getting hung up. But then that one, it happens,
That one's
it's the
slightly
same
different.
thing, yeah, okay.
No, it's slightly different than this system here. All right, let me see if I can get back to the other question here. Okay, let's not do 499 yet, let's do 500. What is ventilating air used for on a combustion heater? Anybody know? Ventilating air used on a combustion heater. Yes, carries heat to the place where needed. Ventilation air. Gonna send it to the vent. That's how I have to remember. Turbine engine air used for air conditioning and pressurizing is generally called what? C, bleed air. Bleed air. All right. In a combustion heater, combustion air system, what prevents too much air from entering the heater as air pressure increases? Good. We either have either a combustion air relief valve, okay, or a differential pressure regulator. All right. Let's stop right there. Let's go out. Oh, let me do one. No, let's stop right there and let's go out and look at the combustion heater real quick. Okay.